Hi, this is Jason with Liquid Instruments. Today I'd like to show you how to perform an Allan deviation measurement using the Moku Phasemeter instrument. We'll be working in multi-instrument mode today, so after connecting to your Moku device, select that option from the configuration screen. We're going to put a waveform generator in slot 1, which will provide our clock signal, and we'll put the Phasemeter instrument in slot 2. Now there's only one connection to be made, so just click Apply Changes and wait for the device to configure. Setting up the waveform generator is pretty straightforward, so let's do that first. Click the icon to open up the menu. Now we want to generate just a simple sine wave this time, so let's change the frequency to 10 megahertz. And the peak-to-peak voltage we can leave at the default of 1 volt. After that, we're going to enable the output, and that's all for this instrument. Now open the menu for the phase meter. We need to do some configuration first before we start taking measurements. If the frequency is currently set to auto, we're going to disable that and change it to 10 megahertz, which is what we set the waveform generator to output. The bandwidth isn't particularly important for this demonstration, but it should generally be as low as possible. You'll see to the left now that there's information about your signal. There's the current detected frequency, amplitude, and accumulated phase deviation, all of which is coming from the phase locked loop and integrator at the input of the instrument. If you click on the graph icon in the bottom right, you can visualize this information in real time. The default plot is a time series, which plots either frequency, phase, or amplitude as a function of time, with the most recent data appearing on the right and moving toward the left as new data is recorded. So let's now introduce the Allan deviation, which is a measurement of clock stability over a certain averaging period of time. In the drop-down menu, change time series to Allan deviation, which is on the bottom, and click Reacquire just so we can start with a fresh slate. You'll see that the general trend is that the deviation is larger at smaller averaging times and drops as the averaging time grows larger. In general, this plot will start to increase again as the time period gets even longer, but don't worry, I won't keep you here for hours to discover that. If you are interested in performing Allan deviation measurements over a long averaging time, you can use the embedded data logger located here and import it to your PC for post-processing. So lastly, just as a bit of fun, let's go back to the waveform generator. And we're going to add a little bit of phase modulation. Click on the Mod button, select Phase Modulation, and set the modulation depth to be plus or minus 90 degrees, and set the modulation rate to be 1 Hertz, so a rather slow effect. Now let's go back to the phase meter. Let's pull up our plot and click Reacquire, and we see quite a different shape emerge at short averaging times. The phase meter is still expecting a 10 megahertz signal, and at sufficiently short times the effect is small. But when you average on the order of the modulation period, the effect is quite noticeable. You'll expect this Allan deviation to go down again at larger averaging times as several periods of the phase modulation get averaged together. So that's all for today. We've learned how to make Allan deviation measurements using the Moku Phasemeter. Thanks for watching, and please visit liquidinstruments.com for more information. See you next time.